Hello, I'm Holly Larson and welcome to my Assessment 4 presentation for Computer Science 105 Section 3 on what we have learned so far. So one of the first things that we talked about were basic email settings such as protect, signature, carbon copy, blind carbon copy, making an email. So here I'll show you that. To make a new email, you go to new message and here you would type in who you're sending it to. You could CC someone that also sends the email to someone of less importance, maybe someone who you want to know about the information but who the email isn't addressed to. You could set a subject for an email. This is where you would put blind carbon copy, where you can send an email to someone without the other people seeing that. The encrypt is very similar to the protect function that we talked about, where the person that you're sending it to can't forward, print, or copy the email that you're sending. And you can also edit your email signature by going to this gear and typing in signature and editing it through this area, and you can automatically include it in emails and such. That's what I did. Mine just says my name and my class year. When I declare my major, I'll probably include that in there, but I'm not exactly decided on that yet. So for email settings, we also talked about Outlook calendar. As I can show you here, you can create an event, you can share it with someone, you can see if they have another event during that time on their Outlook calendar. They can RSVP to an event, you can put a time to an event, you can repeat the event, put a location, you can have even reminders for your event. And such. That's a really useful tool from Outlook to have that calendar there. To share documents, you can screen capture. For Windows, that's the snip. For Mac, it's the Command-Shift-4. So I just clicked Command-Shift-4, this showed up, and I could slide and go like that, and there's my screenshot there, and it's going to show up on my desktop now. But you can also share a document directly from the document. So this is a document I just made. I could click share. The prompt is going to come up to share it. I could copy the link and send the person that link. I could send them an email, or I could also share it with them. It's important if you're sending someone an link that you specify a link. That you can specify whether or not they can edit it through doing that right there. So before Windows, there was the disk operating system on Windows computers. I can't show you on this computer because it's a Mac, but another thing, and these are different functions that you can do with that, which I will show you later on with the Unix, but these are file extensions for files that may be on your computer and what they mean. So a text is a general text file, JPEG is a graphics file, Excel is the Excel spreadsheet from Microsoft Office and such, so you can see from a file in your computer what type of file extension that it has. So Unix is the operating system underneath the Mac operating system. So you can apply commands to perform actions. Here it is right there. I would have gotten there by clicking this magnifying glass and typing in terminal and then launching it. So one thing I could do is I could type in ls and it would list my files there. Here's other commands you could do. You could use Google to find new commands, have some fun with it. And Finder on Mac is used to navigate through files also, which can be done. So cloud file storage is really useful. It's something that Outlook has that you can use. I'm trying to start using it a lot this semester as I'm discovering it, because I used to use Google Drive, but Loyola works through Outlook. So that's a really nice thing that they have. So you could click the app launcher and go to OneDrive and get there, and you can organize files and make folders and everything. Here I have some different folders. You can share folders with people. There's really a lot you can do with that. So that's something really useful that we talked about. And just remember that C drive refers to local hard drive. That's something that I learned in class. So hardware versus software. Hardware are physical aspects of the computer, such as the hard drive. But software are the technological components, such as the operating system. Some operating systems are Windows, Mac OS, Linux. Different devices have different operating systems, which is important to remember. There's a ton of different types of operating systems. for different devices. And Java is a programming language that can be used to make an operating system and such. So another thing we talked about in class was the von Neumann model. One important takeaway of this is that you have to get through the central processing unit to reach the RAM, and the arrows show data flow, so data flows between the RAM and the central processing unit. Storage and input sends information into the computer, and the computer sends information out through outputs, which we'll talk about in the next slide. So some inputs are a mouse, a microphone, a webcam, a touch screen. They flow information into the computer, and information flows out of the computer into outputs such as the speaker, monitor, printer, and such, as shown in the von Neumann model here. So operating systems contain basic operating instructions for systems to function. Like I said before, different devices have different operating systems. I have an Apple iPhone, which uses iOS, and different operating systems have different speeds that are often given, which can be used to compare different not the operating system, the CPU. Oh, this should have been on the CPU slide, but CPUs often come with different speeds that can be used to compare the central processing unit of a device, but the slide is about the operating system of a device, which pretty much just controls the device and is the instructions. So now we're going to talk about the central processing unit, which can have different speeds that can be used to compare, like I set up here, the 3 gigahertz is 3 billion instructions per second. And remember through the von Neumann model that to reach the RAM, information flows through the CPU, and some CPUs are the i3, the i5, and the i7 for computers, and i7 is the strongest. It's just an important takeaway of what that means. So RAM is random access memory. It disappears every time you turn off your computer. Values for RAM on a computer may be 4 or 8 gigabytes, whereas the hard drive has long-term storage for the computer. For example, my phone has 64 gigabytes of storage, and that is always on there, and that's the hard drive. So if I were to turn it off and turn it back on, that's information that would still be there that whole time. So different areas of communication. Binary is binary digit communication. It uses base 2, which uses the 2 digits 0 and 1. It can also be communicated through light, so 1 is considered on and 0 is considered off, is another way binary is used. So for example, 111 is a binary value. Hexadecimal uses base 16, and there's correlation between binary and hexadecimal, but there's not correlation between all different bases. And ASCII is American Standard Code for Information Interchange, which is other values that represent values. It's just a way of communication in the computer world. And a byte is 8 bits, and there's 255 combinations of bytes. And as I'm going to mention later, Excel also has functions to convert values between these different modes of communication, and a subscript can be used to show the base of a value. And so we live in base 10, which I'll go into, but the ASCII table shows values and what they correlate to. It goes up to 255, but this table only goes up to 127, but everything is represented by a byte. And so we live in base 10. Basically what that means is that we look at the number 174 and think of it as 1 100, 7 tens, and 4 ones. And where that comes from is these power rules. So this first number is considered to be 10 to the 0th power. So 10 to the 0th power is 1. So we think of it as 4 ones. Or 10 to the first power is 10. So we think of it as 7 tens. Or 10 squared is 100. So we think of it as 1 100s. And that's pretty much how we think of numbers. But there's other ways that we can think of numbers in other bases. So that's what I'm going to go into, but I'm going to explain the column weight chart to help understand that. So this is the column weight chart is shown here in two different ways with base 2 and base 5. It can be used to show any base. So this number here represents what base it is. So there's 2, there's 5, and pretty much what you do is the first row is considered the power row. And you start by doing power 0, 1, 2, 3, and so on. Here I just did up to 3. On this side I did up to 3 too. So those are the values for that. So let's say I were to be trying to convert something from base 10 to base 2. So let's say, for example, the number 13. So I would use multiplication and subtraction to do this. So to convert 13 to base 2 from base 10 is I would see how many times the number 8 goes into 13. It goes in there once, so I would put a 1 down. I would see how many times, and then I would subtract 8 from 13, which is 5. So now how many times does 4 go into 5? Once. So I'm going to put a 1 there. And then 5 minus 4 is 1, so I'm going to have a 1 here. How many times does 2 go into 1? 0 times. And how many times does 1 go into 1? Once. So the binary digit communication for the base 10 number 13 would be 1101. To convert 13 to base 5 would be a little bit different. Similar, but a little bit different. So first I would see how many times 125 goes into 13, which is obviously 0, so I'm going to cross that out by just making this black. How many times does 25 go into 13 is also 0, so I'm going to make that black. How many times 5 goes into 13? Twice. And how many times does, and 5 times 2 is 10, and 13 minus 10 is 3. And how many times does 1 go to 3? 3 times. So base 5 to 3 is base 10, 13. They mean the same thing. And I would show this with a subscript 5 to show that it's in base 5. And I can check my answer by using the Excel function. So let's say I'll do for this one over here. So, equals decimal to binary. Anyways, I'm running out of time, but that is the column weight chart. So this just pretty much shows that in another explanation. This is the numerical way to put it as opposed to using the chart. And you could go back the other way to in order to go the opposite direction by inserting numbers. So this one important thing to remember when you're working with hexadecimal is that the A equals 10 and the B equals 11 and such. And another important thing to remember is if you have base 10, you're using digits 0 through 9, and if you have base 11, you're using digits 0 through 10 and such. So if you have, let's say, base 5 but a number 6 in it, that's impossible, so that would not be able to occur. And this is pretty much a summary of different measurements of data within the computer world. So a kilobyte is about a 5-page paper. It's 1,024 bytes, and a terabyte is about 1 trillion bytes and such. And this is shown in this data here. And Notepad was just something that we used in the modules to look at different sizes and how much bigger an Excel document would be. And yeah, so that's pretty much it. Thank you for watching, and I'm about to run out of time, and have a good day.